think we're here.
We're here, yeah. Well, we've been out there all afternoon.
We've been there.
Now
we're here. You're there. So that's the top 3 on our checklist done.
Yeah.
So we're going to talk to you about stuff.
The first thing we're going to talk about is about microservices.
When did that happen? When did that happen?
What, microservices?
We said we weren't going to talk about microservices. Yeah.
But that's the only thing I know is microservices, Dan.
We're not talking about microservices, Jim.
Well, what are we going to talk about then?
Not microservices.
Like bang, microservices.
I don't think, yeah, bang, no. The word, okay, so here's what's going to happen.
Right.
This is like aversion therapy. Every time you say microservices, I'm going to hit you with my hat.
What about Docker? Not Docker. I should point out, actually, so we had a number of ideas what we could talk about today. They went through a number of iterations. We settled on microservices, which is awesome for me.
Wait, I'm pretty sure we didn't settle on microservices.
No, we did. We settled on But I'll explain some of the ideas we had beforehand. The first one was, Dan and I used to work together a long time ago now, by which I mean about 10 years ago, maybe?
Yeah, 8, 10 years, yeah.
And probably the last time we paired on any code was about 8 years ago. So the first idea was to come up and just write some code, right? So we'd come up and pair program, write some code, but in the style of famous double acts. So kind of Abbott and Costello, you know, the Statler and Waldorf from the Muppets, Cannon and Ball, Hale and Pace for the
Little and Large.
Little and Large.
Let me figure it would probably take some rehearsing.
Yes. And above all else, it was patently a stupid idea. So we decided not to do that. The next thing was we thought we'd come up and pitch you a brand new scaled agile framework of some description.
Yeah. However, it would be content empty. It would have no content in it whatsoever, no value in it whatsoever. And then we realized that was just pitching a scaled agile framework.
Yeah. You know the kind of thing, lots of lovely diagrams,
yeah,
lots of
it was going to be awesome. It was going to have stuff.
Kind of stuff. Yeah.
Now we've added stuff. Yeah.
So then, you know, the third idea we settled on, fortunately for me, because as Dan, you know, maybe doesn't agree with me on this, but the only thing I do know about is microservices.
No, we're not bloody talking about microservices. We've done this. Okay, here's what we're actually talking about. This is what I thought we agreed we ended up talking about. What we're going to be talking about is how to break the rules. That's what I think we're going to be talking about. So, yeah, I just want to be very, very clear. That's what I think we're talking about.
Right. Okay, well...
You looking blank?
Yeah.
Did you do none of the homework? None of the things I sent you. I said, James, you should probably read these.
No, I didn't.
No.
None of that, no.
You know that thing where you're standing in front of a bunch of people?
Yeah.
Yeah, that.
Well, you mean the ones you've paid?
Yeah.
Oh.
Yeah.
Is this why lecturers in university have to go on courses to learn how to teach?
This is the bit where we were pairing on a talk.
Oh, right.
Yeah. And we were pairing on a talk called How to Break the Rules.
Okay, well, maybe you should start, and I'll see if I can...
Okay, I'll start. You just hop on whenever you recognize anything. Okay, right. So what we're going to talk about today is nothing to do with either of us.
It's Microsoft.
No, it bloody isn't. It's actually about this chap.
And who's that then?
This is Eliyahu Goldratt. Who knows who Eli Goldratt is? Loads of hands. That makes me very happy. Okay, James. So you're going to tell us about Eli Goldratt, aren't you? Because you read up on this and we talked about.
Is he? Was that the?
Let me explain Eli Goldratt. Right. So, shush. Stop saying things now.
I've got nothing else.
Okay, so Eli Goldratt, great management thinker of the 20th century, along with the likes of Peter Drucker and Deming and folks that Diana was talking about this morning. And he wrote in 1984, he wrote a seminal, fantastic book called The Goal.
Which is all about football.
No, James, no, it's not about football. It has exactly nothing to do with football.
What about Scouts?
It has tangential references to Scouts, yes.
So a non-zero.
A non-zero number of Scouts appear in The Goal,
yes.
Okay,
that's good, all right.
Okay, no, so The Goal is, it was one of the first of its kind. It's a novel, it's a business book presented as a novel. And he had an awful lot of trouble trying to get this thing published because he would take it to publishers and they'd say, great, is it a novel or is it a business book? And he'd say, yes. And say, so do we put it in the business section or the novel section? And he went, yeah. And they went, a similar sort of time, book called Zen and the Art of Motorcycle Maintenance, Robert Pirsig. Similar sort of thing, a fable, a story, a whole bunch of learning wrapped up in a book. In the goal then, you have a chap called Alex who's running a factory, and his factory is going through going to pieces, and he's given 90 days, 3 months to fix the factory or it's going to get shut down. And he bumps into
hires loads of scouts at this point?
There are no scouts at this point.
Okay.
Right. So, and he's given 90 days, and then he bumps into an old school teacher called Jonah. And Jonah starts teaching him about flow and lean and stuff and how to see his organization in a different way. And it's a lovely story. About halfway through, you'll be delighted to know there's a bunch of scouts. Okay, and they go off on a hike and some cool things happen, and Alex learns a bunch of stuff by watching the way these scouts hike along a trail. Anyway, don't want to talk about that.
Microservices?
No. Oh. No, there are no microservices anywhere in the goal. So he writes this book, The Goal, and this is in 1984. Now, what happens then is like 20-something years later, 21 years later, he's now been applying these ideas. He's actually a physicist by training, by sort of education. And he stumbled into business management kind of consulting because he realized that companies are very, very broken, usually in very obvious ways. So his kind of overriding thing that he'd learned from physics, and you're a physics buff and you love all that.
Yes.
Yes, even more probably than microservices. If there's one thing that you get more excited about, it's possibly Feynman, I'm going to say.
Well, yeah, okay, fair enough.
There we go. So he's a physicist. So one of his overarching ideas was that no matter how messy things look, there are probably some really simple rules, simple principles underlying that that explains it. And if you can figure out what those really simple rules are, then you can figure out what the system's doing. And I read this book, and it was life-changing. Who's read The Goal? Who's read The Goal? Fantastic. Who hasn't read The Goal? Right, your homework, go and read The Goal. It's amazing. It's fantastic. There's also wonderful, in the later editions, there's a wonderful extended interview with him that I'll mention later on. But yeah, so he does this series of lectures in his sort of later years called Beyond the Goal. Who's listened to those lectures? Who's listened to Beyond the Goal? Okay, a few hands. That makes me happy. They are brilliant, not least because he's kind of narrating them himself. And he's this old Jewish guy, and he sounds like an old Jewish guy. And old Jewish guys are brilliant at telling stories, right? And so he's telling these stories, and every now and then he'll laugh at his own jokes. And he goes, he's got this like lovely old guy chuckle. But so what he does is at the start of Beyond the Goal, he basically drops a thought bomb. He just says, right, it's just really one sort of simple sentence. He says this. He says, technology can bring benefits if and only if it diminishes a limitation. Okay? So that's the magic words that he uses. He says, if and only if it diminishes a limitation. Got some weirdness happening on my laptop. See if we can make that go away. Okay, so, and then what he does is he then proceeds over the next lecture or two to kind of unpack that statement. And it turns out there's some quite profound implications of the statement. So what we agreed, Jim, if you remember, with all our emails and phone calls, and beer, oh, that'll be where it went wrong. Okay, was that we were going to start unpacking.
Hang on. Carry on.
There's beer. I see beer. Fantastic. Start unpacking this statement. So he says, yeah, technology can bring benefits if and only if it diminishes a limitation. Now, his observation then is this. His observation is that we are really, really bad at adopting new technology. Okay? What do you mean by technology? Technology is anything, any application of knowledge into the real world. So for technology, you could substitute the word innovation. So it's applying ideas. We're really rubbish at adopting new ideas. In fact, he's a bit more precise than that. He says, we're really, really bad at benefiting from new technology. And the reason we're bad at benefiting from new technology is the way we set ourselves up means that we systemically resist taking on new technologies. And so what he does in his lectures, he uses a couple of examples. So what I'd like to do, what we're going to do, because James and I practiced this. Did you practice? No. I'm going to tell you a couple of examples of Ellie Goldratt's from these talks, and then I've got another couple that I want to kind of add in terms of kind of trying to illustrate these ideas. So the first one we're going to start with is MRP. So, James, MRP, take it away. What?
Okay, so can anyone help? Does anyone know what MRP is?
Anyone know what? Nope.
Minimal releasable product.
There's Mr. Grenning's hand is up. Mr. Grenning, would you like to enlighten us? Fantastic. Manufacturing resource planning or materials resource planning. MRP is the thing that so MRP was the reason that the first business computer systems were written. So this is back in the probably 60s, maybe 70s. One of the very first companies to use computers outside of like the industrial military complex type thing in the US was DuPont. And DuPont was this huge manufacturer. And so MRP is this, I have a factory of any kind. I manufacture something. And what I need to do is plan how much resources, how much material I'm going to need over the next period. Okay? So what do? I look at my order book and I see what orders I've got coming in. And then I figure out, based on those orders, what the items are, based on the items, what the pieces are, and based on those pieces, then I can go and order those and make sure they come through. However, there's a lead time on getting hold of the pieces. And anyone who is in any of there's several talks today that have been talking about kind of cost of delay and lead time and value stream mapping and all that kind of good stuff. It's a really hard problem. So once you've got any kind of non-trivial manufacturing scenario, figuring out how much material you're going to need is really hard. And so what would happen is you would have a gang of people, like manually in ledgers and whatever, doing the calculations. And in a factory with maybe a couple of hundred people, literally a quarter of those people might be very skilled kind of accountant type people who would be doing these calculations. And the calculations might take a week to figure out the materials plan for the next month. And so that was basically what would happen is every month you'd do your materials resource plan and it would take a week. And so obviously you couldn't do it any more often than a month because it takes a week to do the calculation. DuPont said, this is maths and computers do math, let's get computers to do it. So they commissioned a system, and the system then was able to do this MRP calculation overnight. And they were like, this is pretty cool. Yeah? So now they had the system that could do the MRP calculation overnight instead of in a week, and they started absolutely wiping the floor with all the other US manufacturing companies, and that's one of the reasons they became so big. And so everyone else then jumped on this, and they said, oh, we want MRP as well. So now you suddenly had commercial computer companies selling this MRP software into companies. But then what happened was this. None of the other companies were benefiting in the same way DuPont was. And Goldratt lived through this. He was kind of, he's a lot older than us, and he was doing systems in the 80s and whatever. And he said he didn't realize this until much, much later. But what he realized is there are four questions, you like, that we need to understand, we need to unpack in order to benefit from a technology like MRP. He says we've got these four questions. And so the four questions look like this. So the first question is this. It says, what is the power of this technology? Okay? What is the power of this technology? So what benefit, if you like, does this technology give us? Yeah? And then that's an easy question to answer, because that's like, what's the sales pitch? What's the brochure say? Right? The person selling you the technology will tell you the power of the technology. Remember the statement, though. It's a benefit if and only if it diminishes a limitation. So the next question, what limitation does the technology diminish? Okay, we need to be able to understand what limitation it diminishes in order to know whether it's effective. Here's where it gets interesting. Because we had that limitation, we were living with that limitation, and so now what we need to do is figure out how we were living with that limitation. So what rules enabled us to manage that limitation? What rules did we have in place such that that was true? And then finally, so now we can really exploit this new technology, we ask this question, what new rules are we going to need to exploit this new technology? Okay? And by going through each of those questions in order, that's how we get the benefit from innovation from technology. Mostly, we stop at one. Sometimes we stop at two. We very rarely look at the rules, and we very rarely look at what new rules would be. And this is a rascal, and it's a rascal because the rules are hiding in plain sight. So let's take a look. Let's look at our MRP example. So let's apply the four questions we've got to MRP then. So what's the power of MRP? What thing does it give us? It gives us time. It gives us the ability to suddenly magically do this 1 week calculation overnight. Okay? So we can carry out complex MRP calculations overnight. That's brilliant. So what limitation does that diminish? Manpower, time, effort, cost, all those things, right? So, it used to take an entire week for a skilled team to carry out the calculation. And that was the limitation. What rules then, from that story, what rules enabled us to manage that limitation? What were we doing? Yeah, so we've got to get all the inputs for that stock and order calculation. How often are we doing that? Once a month. Why? Because limitation. Yeah? So we can only plan monthly, right? Otherwise it gets too expensive. We can't plan weekly if it takes a week to do it. Okay? So now what new rules are we going to need to use in order to exploit this technology? We're going to need to plan more often. Okay? And we need to change a relationship with our suppliers and with our customers. So if I can now plan on an almost ongoing basis, so DuPont goes down from like monthly to fortnightly to weekly to almost daily, that doesn't actually benefit anything if our suppliers are still expecting to take a monthly order. So we now need to go into our own supply chain and start helping those guys work much more small batches. Toyota had this problem. As they were starting to understand the power of lean in the 50s and 60s, they would then go into their supply chain, and often they were competitors, and make them more competitive so that they could go faster. And they still benefited. And a lot of organizations won't do this. Okay. So
how does this relate back, because you mentioned a minute ago about other organizations trying to adopt this and failing. So what was the, why were they failing?
Great question. So why were they failing? Why were these other organizations failing? They weren't using microservices. John Chapman, you're exactly right. They weren't using microservices. That's the reason.
He'll come and hit you with his hat.
I will come and hit you I will beat you to death with my hat. So, okay, that may well be one of the reasons. No, the reason was they hadn't got past step 3, right? They still had that constraint. And so for them, the rules become policy, okay? And this is the situation there, and the rules became policy. So I was drying my hands in the men's room earlier on, and I noticed on the hand dryer there was a little label. And of course, James and I have been kind of chatting about this for a while, so I've become sensitized to sort of looking for information on these little labels. And I couldn't help noticing something. So it's a thing called green spec, and Kevlin Henney mentioned earlier on, this is not an environmentally friendly BDD framework in any sort. This is just a hand dryer in a toilet. But it does say something rather interesting. It says, not suitable for drying hair. Right? Now, someone making a hand dryer for a toilet has decided to put not suitable for drying hair on there. What happened? What happened? A, enough people must have been attempting to dry their hair that it became a thing. And B, they were probably getting injuries, right? So this is what happens, is that these constraints become policy.
And this is what I think Badara Dave Thomas talks about when he talks about scar tissue in organizations, isn't it? This is
absolutely.
How organizations build up scar tissue as a result of failures in the past and things.
Yeah, and while we're talking about BDD, I see this scar tissue a lot in where people, TDD, where people, there's that old saw of like, as soon when you have a bug, oh, fantastic idea. While we're talking about BDD, we have some BDD beer here, fantastic. He says, showing beer to people so we are now standing between all these people and beer, drinking beer.
But you have a hat.
We just became hate figures, you know that, right? Okay, so yeah, and so the thing, as soon as you find a bug, the first thing you do is write a test that proves the bug. Great. And then you fix the bug, and then you refactor and check it all in, and that's good. But what happens if you keep doing that is over time you end up with loads of tests that were just really weird bugs. And most of them are just dumb coding errors. So you get a test that says things like, do not pay twice as much for Kit Kats on Thursday at 2 p.m. And you've got a test that says that. And you go, of course you wouldn't. That's a stupid rule. Right? And so I've got thousands of these things now. And again, it's scar tissue. There's loads of noise there and no signal. So, okay, next example then. Again, this is Ellie's second example from his talks. He talks about ERPs. So this is ERP system. So you know about ERP systems.
I know this one. This is good.
Yeah,
I got
you
this
got
one.
this.
Yeah.
Okay.
So this is it's that thing where you've got lots of different systems in your organization, and you need to get them to communicate. It's like a fancy message bus, right?
Oh crap! No, that's not ERP. That's ESB.
E-
That's ESB. You're thinking about ES. That's not ERP.
No, that's a beer, Dan. ESB is definitely a beer.
No, ESB. No. ESB isn't a beer. BDD is a beer.
BDD is a beer. BDD is a beer. Okay, well, what on earth is ERP then?
ERP. What's ERP? Enterprise resource planning. What I love is that half the room knows that because we all suffered from those systems and are still suffering from those systems now. So that's the 90s, right? Most of us weren't coding in the 80s. A lot of us were coding in the 90s and have the scars to show. So ERP systems. So ERP systems were again game-changing. What the magic they did was this, was they brought information together for the first time across an organization. So this was the first time now an organization had a holistic view of data going on. And so until then, what would happen is we had this thing called cost accounting. And cost accounting says, I'm in marketing. I can't tell what the engineers are doing. I can't tell what manufacturing is doing. I can't tell what sales are doing because I'm in marketing. And that information is distant from me. So all I can do is optimize marketing. Likewise, over in engineering, they're doing the same thing. Let's optimize engineering. So we optimize for utilization. We optimize for reducing cost locally. And all these local optimizations, once you start understanding flow and those kind of things, you realize these local optimizations are bonkers. Yeah? ERP systems, all they did is brought all that information together and said, here, you can have reports. You can have near real-time data on every part of your organization.
When they worked, right?
When they worked.
When they didn't actually bring your entire company down and make it go bankrupt.
When they didn't bring it down and make it go bankrupt. And also, when you bothered using them. Right? And here's the fun. So let's unpack that. So let's apply the 4 questions to ERP. So what's the power of ERP then? What's the magic thing that ERP gives us? It means we can collect, process, present information all across the organization into one place. It's like magic. This data was already existing, but it was in lots of little pockets all over the place. And in a large organization, even within the same division, there were pockets all over the division. So you had loads and loads of local optimization. So what limitation does it diminish?
Am I supposed to know the answer to that?
So.
I can see the slides, so I kind of do now. But.
I can cheat and look ahead. I'm having some operational fun and games with my new clicky pointer. Diminishes ignorance of what other groups in the organization are doing. Okay? So now that means we can start to take a holistic view. So what were our rules? What rules enabled us then to manage when we didn't have all that information? And as I said, that's cost accounting, right? Cost accounting is utilization. It's who here has timesheets and project codes and cost codes and, depressing number of hands going up. It's really unfortunate. And so now what new rules are we going to want to adopt? And this goes straight back to the goal again. In the goal, Ellie Goldratt posits this idea of what he calls throughput accounting. In throughput accounting, there's only 3 metrics, only 3 numbers. There's inventory, which is how much you've spent on stuff that you're going to turn into product. There's throughput, which is how much you've turned into money. So he doesn't talk about throughput in terms of items going through. He talks about throughput in terms of you making money from stuff going through. So making cars and filling up a field with manufactured cars isn't throughput. That's more inventory. It's only when you sell the cars that they turn into throughput. And the last one is operating expense, which is all the money you spend turning inventory into throughput. That's the whole of accounting. And it turns out that all of the cost accounting numbers you can derive from those 3 numbers. Okay? So what do we need then? What we need, and then because we've got local cost accounting, we start seeing parts of our organization as revenue generation and value creation, and parts of our organization as cost centers. Okay, so IT is seen as a cost center. Who works in an organization where IT is seen as a cost center? Answer, we all do, right? Unless you're in one of those cool startups with all the 4-letter words, right? We all do, yeah? So what do we want to do? We want to use throughput accounting. We want to measure flow. We want to measure value. So this is all the Don Reinertsen wonderful product development flow stuff, yeah? So these are the things we want to do, the new rules that we're going to need, okay? And now suddenly all the values are part of a value chain. They're part of the creation of value through the organization. Engineering, R&D, manufacturing, sales, marketing, it's all part of one big system of work that turns ideas into inventory, into throughput, okay? Which is kind of cool, but now, that's interesting. So where do we go from there? So now we start to see this. We start to see that these limitations, these rules, become law. Okay, they become so institutionalized, every listed company has to publish quarterly numbers against their cost accounting rules. There's a set of rules called GARP, GAAP, Generally Accepted Accounting Practice. And those rules are things like PBIT and a whole bunch of other acronyms of values you have to publish as a company so that an investor can compare like for like. The fact that these numbers are practically meaningless and demonstrably meaningless doesn't matter. We literally need to change the law, okay, in order to be able to exploit this new technology.
I can give you a pretty weird example from a client I was at fairly recently with respect to actually a technology purchase. So organisation spent tens of millions on some hardware.
I find that hard to believe.
Yeah. Realised sold by a big hardware vendor. They probably got some golf clubs, you know. And essentially, they realised after about 6 months that this hardware that they'd been sold would never work with the software that they were going to put on it. So the sensible thing, you might think, is to not use this hardware and use something else, because it wasn't going to do the thing that they thought. Unfortunately, because law, because cost accounting, because rules, they weren't able to do that, right? Because that hardware was already on their balance sheet with a 7-year write-down period. So for 7 years, they had to keep using that. Otherwise, they'd have to declare 15 million quid or whatever as a write-off to the market, which, if you're the CIO, makes you look really, really bad. So yeah, this is a real issue in lots of places.
Well,
and in weird places that you wouldn't think.
You reminded me of a project I was on back in the day in Thoughtworks, probably about 2005-ish, where a lot of the continuous delivery stuff came from. Where we had, we were trying to build some new environments, so we'd have more and more test environments because we're massively constrained in environments. And the organisation was an American company, we were in the London offices, and they said, we have some tin in the States that we're going to ship to the UK for you to use. And we're like, what's the spec of this tin? And it was like about 5 years old, and it was basically, that was a time when tech's always moving fast. So this 5-year-old, really under-spec'd hardware, they put on a ship. In fact, we knew when they put it on the ship because one of the guys, I think it was Sam Newman, was pinging a server and then it disappeared. And they said, my server's disappeared. And they said, yes, it's on a truck. They went, okay. And so then they shipped all these servers at great expense over to London because their shipping costs, their logistics costs, they were well under budget on there, but they had to write down this CapEx on the servers. So these servers all arrive in London, at which point we reminded them that their data center was in Luxembourg. So they then packaged them all up again and sent them to Luxembourg at more vast expense. And a chap called Dante Briones, I'm sure you remember Dante Briones, lovely, lovely developer, very smart guy. He did a bit of a back-of-an-envelope calculation on the spec of these servers in terms of CPU, storage, memory, that kind of thing. And then he did the same back-of-an-envelope calculation on his iPod. It was about a third-generation iPod with the little dial, if you remember those. Yeah. And it turned out, guess which one? So he figured that we could actually get better performance by having an array of iPods than the very expensive hardware that are just shipped to 2 European locations.
That's nice. I'd forgotten that one. There's another example, actually. We found, this is like a sub-Kevlin kind of thing. It's not errors, but they're amusing things we've been finding around the place. And this one relates to also law, but health and safety law. So do you want to flick on?
Yes. This happened quite recently, didn't it? Yeah,
so if you've been into the lift in the foyer over here. So this is the sign in the lift. Obviously, we're in a theatre complex. You have to move lots of props and things around. So these are the rules that govern how you move props around this building, if you need to move props around. Now, look at some of the things on here. See if you can pick out anything that might have been caused by maybe organizational scar tissue, things that occurred in the past that would cause rules to build up. So be safe, attention. Do you want to, if you can see that, we can maybe zoom in, Dan, can't we, I think? Yeah,
see if we can do that. We can if there we go.
Yeah. Ensure you are wearing appropriate clothing, including shoes. People are very worried about shoes. Is the load heavy? Awkward to lift? Does it have sharp edges? And down the bottom, remember, do not rush. Note what needs moving. Plan and clear your route. Wear appropriate clothing, including footwear. Underlined. Right? This is underlined. This is true. And actually, serendipitously, we were sitting out there sort of going through some of this. And there's a guy walked past with a big prop thing, like a trolley and a big thing on it, and he walked towards the lift. And we were laughing about the lift and about this thing. And he said, I think we asked a question. Has anyone ever hurt their foot? And he said, oh, yeah, the student nearly broke their ankle last year. So now we've got this thing in the lift. Yeah, health and safety, scar tissue, literally in this case.
This is where this is where things become law. The rules of moving stuff around are wear shoes. I love the idea that you'd be moving heavy stage equipment about in your flip-flops, right? Because why wouldn't you? You know, you're by the beach, right? So, yeah, okay, so our next example then, sort of bring ourselves a bit more up to date, is I want to look at cloud. I think cloud, the advent of cloud computing is probably one of the most significant things in my lifetime, certainly in the last 10 years. And there's a number of contenders for invention of, or the person who could be said to have coined the term cloud. You've got John McCarthy, who famously created Lisp, or described Lisp, at least in a paper, is one of the first people alleged to have used the word cloud. A chap called J.C.R. Linkletter, who was one of the leads at DARPA, the US Defense Agency, that invented ARPANET, which became the internet. And he very, very early on mentioned cloud. The first time we really saw cloud as a commercial offering, as a large-scale offering, was around 2002. Jeff Bezos had famously shouted at everyone at Amazon and said, everything we do now will be services. So if you want to book a holiday, they go through HR. There has to be a service that they offer through an API. If you want to get hold of a server, that's another API. If you want to get compute power, if you want to deploy something, that's another API. So the whole company was working on APIs. And he was like, we've got a heck of a lot of tin. And we mostly use that tin twice a year, right? Christmas and Black Friday, and that's basically it. And the rest of the time, it's just sitting there humming away. We could rent that tin out. And so because he had all this policy around APIs, he just opened those APIs out to the world, and that became Amazon Web Services. And so there's a lovely quote, a chap called Thomas J. Watson, who was the original CEO of IBM, or he was the CEO of the company that he then renamed IBM. So he was there for like 40-odd years, and he famously said in the 40s, he said, the world will never need more than 5 or 6 computers. Who's heard that quote? Yeah, right? And everyone went, and then we go, well, Google, Amazon, Azure, right? Bluemix. I reckon we're going to end up with about 5 or 6 computers, right? They're just bloody big computers. And I think he was maybe 50 or 60 years ahead of his time. This is not a computer. This is an access node to the computers. Ooh. We just weren't thinking big enough. Yeah. So cloud comes along, and cloud completely destroys the economic model of how we deal hardware. Exactly what you're saying, James. The CapEx 7-year write-off, the amortization, the cost per use, all of those things are CapEx thinking. And so now let's take a look at this in terms of our four rules. So what does that mean? Well, what is the power of cloud? What is the power of this technology? What does it give us? Scalability. Yeah. Commodity on demand, right, this is it. We've got on-demand compute power. Everything else is a derivative of that. The primary thing we get is on-demand compute. We've never had that before. We had to plan it before. We had to buy it before. We had to usually overbuy it because underutilization, someone just gets told off, right? Overutilization, we don't have enough compute capacity to deal with peak or whatever it is.
We don't sell more trousers.
We don't sell more trousers. And also, right in the middle of needing to sell trousers, everything starts crashing around us because capacity. So we tend to massively overcook this, right?
We used to call this the startup tax, if anyone's ever heard about this. This was like one of the main reasons, I think, it's recognised that we've got so many more startups now, is that we don't have to pay this startup tax anymore.
Well, and this is, yeah, and so the first dot-com boom versus the second. So the first dot-com boom, everyone was looking for investment because I need to get out a data center, right? If I'm going to be the next eBay, right? There's already been one eBay. I'm going to be the next eBay. I'm going to suddenly have 10 million users. That's not going to. I'm going to need a bunch of tin, right? Now I don't need a bunch of tin. So it diminishes the cost and risk of running your own data centers. They're enormously risky undertakings, and they're enormously costly. And I need to front load all that with planning. Anyone working in a big company, you'll probably have some internal infrastructure group, and the infrastructure group works on an annual budget cycle, an annual planning cycle, so I have to decide now how much tin I'm going to buy for the year. Yeah? So what rules enabled us to manage that world where we're thinking about CapEx? The first rule is this. We all agree that hardware is expensive, okay? And it requires loads of governance. So we have loads of governance. We have loads of stuff going on. Loads of oversight, loads of people need to be involved in the procurement process. It's a heavyweight process. What else? we need lots of people, lots of different people, typically in silos of specialisms and expertise and all that kind of stuff. Okay? Those are the rules that enable us to manage this massive bunch of stuff, of hardware that we've got. So what would new rules look like then, maybe, that enable us to manage to exploit this whole cloud thing? What would that look like? They're going to look like things like the ability to explore new ideas. And this is exactly what you're talking about, James, with the startup tax. The startup tax goes away. The startup tax is I can get through 6 product ideas in a morning. I can spin up 1,000 servers in 10 minutes, and they're not even my servers. We don't know how to process that, or at least most organizations' governance models don't know how to use compute on demand. And the thing that really landed for me with this, in terms of especially some of the conversations I have with some of my clients, which are large, large retailers, large banks, large financial companies, the concept of reducing compute power is just tilt. They don't understand that. If it's okay if we massively overestimate and we discover by measuring that we're massively overestimating, because we can dial it down again and it costs us nothing to have got that wrong. So in options terms, in real options terms, the cost of reversal of that decision is negligible. Right? The cost of reversal of spending $1 million too much on kit, well, I've got to suck up that cost over X period of time.
And this goes back to what I was saying about that example of writing down cost over time as well. I mean, like, if you're a big organization just to decide to go cloud native and you've got data centers all over the place with a ton of kit, what do? Do you write all that off as a 50, 100 million pound loss? Again, you look pretty stupid. Yeah. Back to law.
Back to law and policy and reputation. So in this stage now, rules have become structure. So we start building organizations around some of these constraints. Okay? Someone not a million miles from me has talked about Melvin Conway on a number of occasions.
Meantime to Conway reference.
Meantime to Conway reference at minute. Okay. So
I think there's another thing. I mean, I see this quite a lot when I speak to our clients as well, is that you're stuck in this kind of mode of thinking which is very data center centric. So rather than think about the possibilities that you get moving to the cloud, you think about the constraints and you take the same rules that you're applying with you. So the classic example, I think, would be something like business continuity planning or failovers, disaster recovery, right? I mean, Adrian Cockcroft, when he was at Netflix, he famously said, what do you mean disaster recovery? We don't do disaster recovery. We just use Europe for UAT, right? If you're always on, all the time, if you're that available, there is no concept of having a disaster recovery plan. You're just always on, always available. And when we apply the same thinking, you don't get to that same place in the cloud. So. Yeah.
While we're doing Adrian Cockcroft quote, one of my favorite Adrian Cockcroft quotes, he's talking about, like, because he was the chief designer of the whole migration of theirs to Amazon and their whole kind of resiliency strategy, was he said, what I managed to do there over several years was build one of the most sophisticated monitoring and alerting systems I've ever built in my entire career that as a side effect can stream video, which I thought was rather lovely. So the final example I want to look at then is continuous delivery. So in this world now, and this, in this world now, so I was around at the beginning of continuous delivery. So one of my things I'm most proud of actually at Thoughtworks, there's a couple of things I'm very proud of from Thoughtworks. One was I managed to get them to hire their first environments engineer, so operations specialist, because this is about 2003. Everyone there, all the developers were kind of were developer, would do all the ops stuff. I was a Linux admin as well on the side. Most people were. And I met this chap, Julian Simpson, now known as the Build Doctor, phenomenally smart guy, brilliant ops engineer. And I said, we need to have those. And so, no, we don't. We're all generalists. It's fine. So I managed to get this guy, snuck him in under the radar. And the first project he landed on, people are going, where can we get another 6 like that? And then, so shortly after that, a couple of years after that, I'm working on a project, and we've got these 4 teams of about 10 people slamming a tiny number of contended. This was the gig where we shipped all the kit over from the States twice. And part of the way through there, I was growing this team of build engineers, and we ended up with about 8 people in a build team, which is 8 too many people in a build team, just for the record, right? But so as we're growing this team, one of the people we hired was a chap called Jez Humble, this young lad, quite sweary, killer smart. And so I think one of my favorite things about sort of my time at Thoughtworks was hiring Jez and sort of becoming pals with him and learning from him. So a lot of the work we did there, he and Dave Farley then took forward and turned into this book, this wonderful patterns book called Continuous Delivery. So at the time, right, the problem we're looking at is that releasing software is really hard, and it's error-prone, and it's manual, and it's flaky, and it would take us like literally 2.5 days to build out a build for some testers to work on. Integration and testing was a rascal, okay? And so you had huge amounts of ceremony, like sign-offs and change cabs, change approval boards, and all this guff, yeah? So CD grew out of necessity. It wasn't, let's go and invent continuous delivery. It was, let's try and get some work done. So again, we can apply these 4 rules, and then what I want to do with James's help is kind of start tying all this stuff together for you. Let's start looking at the 4 rules of continuous delivery. What is the power then of CD? What is the power of continuous delivery? What does it allow me to do? So what it allows me to do is it says I can, and this I was very specific about the language here. I want to eliminate, simplify, and automate. Yeah, eliminate, simplify, and automate the release of software in that order. So back to, if you're in Osmond's fantastic talk this morning, where she's talking about like mapping value streams and looking at where all the waste is, the first thing you do is just take all the crud out of the pipe, because there will be a load of residual scar tissue process, meetings, governance, crap stuff. Get rid of all of that. Then whatever's left, simplify that as much as you can, make it kind of standardized and whatever else. Then, only then, look to automate it. So this is the power of it. What limitation does it diminish? It's the risk, it's the transaction cost. So anyway, these kind of really long nights or really long weekends of releases and all that kind of stuff, very risky. People are terrified of them, so we shield ourselves from them.
And we don't do them very often because we're terrified of them, and they become more risky, so you get this vicious...
Yeah, exactly, yeah. So we've got the right lever, but in the wrong direction. We don't like doing releases, so let's do them less often, yeah? And so what are the rules then? What are the rules that enable us to cope with this? We assume that fixing any mistakes are going to be expensive. And so we front load all the risk, and we have this huge amounts of stuff going on, yeah? And we're saying it's going to be time consuming, it's going to be long, it's going to be expensive, and it's going to involve people working late into the night. So we need to flip those rules around. What else does it tell us? It tells us that we need specialists, again, to manage these releases. So I need a release manager or release engineer. I need my security person, my compliance person, and all these specialists all the way through in order to get a release done. Okay? So what new rules, then, do we think are going to help us? Well, the first thing is we want some kind of self-evidencing process. So if we can get a path to live that tells us that it was this build, it was released from James's machine, he was pairing with Dan, they checked out this build number, or this commit number. So it's self-evidencing all the way through, applying metadata to the static binary. And then as that binary goes through its different environments, it gains those Scout metadata tags. So it's got the performance tag, and it's got the security tag.
Scout?
And it's got the
What?
Scouts.
Okay.
Yeah. Not Scouts. Not Scouts, no.
Oh.
Scouts. Yeah. So we've got little Scout badges that are from different environments. And then we can define what good looks like for a release. So we can say for a release build, it needs to have yada, 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 all these different metadata things. For just a regular kind of exploratory testing poking build, does it necessarily need to have its performance testing badge? Probably not. As long as I can spin it up and make it do stuff, that's probably going to be enough. So we can start getting a bit of optionality in there. And the other thing, in order to really benefit from continuous delivery, is we want to slice things into small, valuable pieces. And that's hard, right? That's where this whole now discipline of product management has come out of, is what does small, valuable slices look like? So John Allspaw, famously CTO of Etsy, he said, we don't have rollback. There is no such thing as rollback. There's roll forward. If you're doing hundreds or even thousands of releases a day, James and I put our release in, we go, oh, it's broken. By the time we've gone, oh, it's broken, 7 other releases have landed behind it. Right? You're going, da-da-da-da-da-da, and we're going, oh, what does it now mean to back out in that context? We can't. What we do is we do another release that's the undo of ours. So we can release an inversion, but there is no back out. There is no rollback. There's just forwards. Yeah? And this is a huge deal. So by this stage now, when we're looking at something like continuous delivery, what are the rules doing now? The rules now have become culture. They become the organizational constraints. And this is why continuous delivery and DevOps is such a profound shift in organizations. It genuinely impacts the culture. You're changing the rules underneath. So basically, those 4 examples are where I wanted to get, and just describe some of these things. And now what I want to do is start kind of weaving it all together into you bastard.
So this is part 2.
I leave you with my deck for 5 minutes. I leave you with my... What's this?
Docker.
Carry on.
That's on film, dude.
Carry on.
That hurt.
It's assault. Carry on. Keep going. I don't mind. You're
So I'm going to talk about microservices now.
well, go on.
Just very briefly.
Go on. Okay.
Kind of
I'll give you
running
this
out of
one.
time,
I'll give you this one.
I mean, microservices is the same.
You said it again.
Quite a profound change. I can't do a thing about Docker. Again, this has been a reaction in some senses, and I think Dan and I were actually both there when we sort of first talked about microservices, calling them micro applications back in 2011. In Italy, it was at a software architecture workshop. And the reaction we were feeling at that workshop was against monolithic applications, was against the fact that they were hard to change, difficult to scale teams around. That was the prevailing mood when we were building software, is to build quite big things that became kind of constraints on us. And what's kind of, I guess, been the sort of defining characteristic of microservices for me has been it gives us the ability to change things more easily, break things up into smaller bits, which is what microservices are, which means we have more options to do more things in the future. So we have more options to scale people around things, we have more options to throw things away, we have more options to replace them, etc. So this is why I think where microservices has come from. However, I mean, if anyone's who's worked in a team building microservices? All right. Is it easy? Lots of shaking heads. No, it's not, right? Because I mean, Martin Fowler has this lovely line. He says, "It exchanges. It means you can focus on essential complexity in your code, but it pushes out accidental complexity into your infrastructure. So you end up with a lot more complexity in terms of operating them, in terms of monitoring them. And if you're in an organization that isn't used to that, suddenly landing another 50 applications onto your ops team and saying, look after that, is not necessarily a good idea. So what happens if we apply these rules to microservices then, Dan? So the first question, right? What is the power you get from building software using microservices? So this is that we can essentially deploy and manage unrelated things. We can make changes to these things independently. We can have more teams scaled around them and so on. But what are the sort of limitations that are diminished? So those limitations are diminishing risk and uncertainty, essentially, of making changes in large apps. So when we have lots of people making changes in the same place, it's more likely that you will stand on other people's toes. It's more likely that your changes will conflict. It's more likely you'll get longer release cycles. It's more likely that testing becomes harder. You have to test the whole thing, and so on. So what were the rules we had for monolithic applications?
Well, and one thing to add to that is because we've got this coupling, we've got accidental coupling, structural coupling, means that say I make a small change in an innocuous bit of code over here and it ends up having some unfortunate consequence like a memory leak, it means I end up taking out the entire monolith.
Yeah.
Right? So this is now, so where I'm trying to break down that risk and uncertainty is we end up with an almost exponential, or probably worse than exponential, combinatorial problem of impact analysis, of impact assessment. So the blast radius of even tiny changes becomes really huge, right?
It becomes huge, yeah, exactly. So what are the things we had to put in place, the rules to manage building monolithic applications? For example, small changes, you have to scrutinize small changes, we have to do code reviews, we have to do all sorts of, they have these change release boards and things. So you get this sort of scrutiny and oversight of change. And then there was another thing called feature branching. Right? Feature branching is a very common pattern that you get building monolithic applications, so you can work on parts of the code independently. Right? And you get this very infrequent big integration problem, so you spend a couple of days on merging changes together. So what are the new rules that we need? A couple of new rules, I think, in this case, which Martin and I try and stress as almost like prerequisites if you're going to be building microservices. The first one is that every component should be discoverable and monitorable. So it should advertise itself as around, aware, and up, for example. And also, another rule is that you can have small teams that build around separate code bases. All right, so you have small teams looking after small parts of the business domain, delivering software independently from one another. This is kind of interesting because the implications of building software in this way are pretty profound. I guess we'll look at that now, right? Because this is not just, and if you've worked on a team building microservices, it's not 101. It's actually a change in paradigm of how we build software fundamentally. So it's completely different to how we build software, completely different to how we architect software.
And this is huge. So all of those previous constraints, all of those previous ways in which the rules have been working, I was actually quite glad that James snuck this into the deck, because all of those things we can manage, right? As people, as teams, as organizations, we can manage. We can manage changes of structure, we can manage changes of policy, we can manage changes of law eventually, right? We can manage changes of culture, those are fine. Paradigm's a technical term from behavioral psychology. It's your mental model. It's the filters through which you perceive the world. It's your sense of what right is or what normal is. And so what happens, and this is like the matrix, right, is when you find out that something is profoundly different in the world, it's deeply uncomfortable. As human beings, we really struggle with this. And actually, Ellie Goldratt says in The Goal, at the end, there was a lovely extended interview with him at the end of The Goal. And in it, the interviewer asked some pretty candid questions. He says, like, so, this theory of constraints, this goal stuff is brilliant. It's clearly right. So why aren't organizations using it? And he says, he says, like, how long does it take an organization to pick up theory of constraints? So imagine you're going to go in, you're going to talk to this guy, or he's going to talk to you, and he makes a lot of sense. And then how long do you reckon he said, on average, it takes for an organization to adopt his ideas? 10 years, 20 years, wow. A year. Yeah. You guys are pretty close. He said his experience between 5 and 15 years. And the interviewer says, what? And he says, yeah, between 5 and 15 years. Because it's a paradigm shift, right? It's a shift in mental model. And people will do anything before they'll be screeching their fingernails along before they'll change their paradigm. So you need 3 characteristics, 3 things to be true in order for that to happen. The first thing you need is kind of downward pressure. So you need some impending disaster or whatever it is. The second thing is you need to have run out of options, right? You've tried everything and now you're desperate enough to try this crazy thing. And the third thing you need is information. And he said, I'm good for the third one. So what I do is I make friends with organizations and wait for the first 2. And that's his business model, right? Just hang out and go, oh, now you're in a hole, now you want to talk to me. Okay, now let's try it. And so the more enlightened organizations will force those first 2. They'll say, we're going to try this thing, and we're going to give ourselves a deadline, and can you come and help? So, okay, and so the paradigm shift thing is massive. So let's take a look at how we can use this then. How do you break the rules? Well, now what we can do is we can invert those questions into statements, and that can start giving us some ideas to do this. So let's understand the power of the technology. What can it do for us? How does it work? And how will we know it's going to work for us? Yeah. So the second thing we're going to do, remember we're saying, what's the limitation? Well, how do we understand? How do we recognize the limitation in our own organizations? How do we measure that? How do we prove it? How do we know that it's a limitation? And also, what metric would we use to see it trending downwards? Is it reduced lead time? Is it reduced cost of delay? Is it whatever those business metrics are? Is it those? But they've got to be flow metrics, throughput metrics. We want to identify the existing rules. This is really hard. I can't overemphasize this. They're hiding in plain sight. Those rules are hiding in plain sight, and that's why they're so hard to realize, and that's why we become so institutionalized. And finally, and this is, again, once we start unpacking those rules, right? How do we get the new rules in? How do we institutionalize those? How do we make them normal? Yeah. So I just want to work an example then. As I made you a thing, James. I made you a thing. I brought you...
Oh, is it a microservice?
No, it's not a microservice. No, I brought you the moon.
A moon? A moon, okay.
I give you the moon.
I don't think that's a moon, Dan. That's no moon. No, that's actually a Death Star, isn't it? Yeah. Okay.
Emperor, I bring you a Death Star. So, right, we're going to role play this. You're going to be Darth. Right, there you go. You're going to be Vader. I'm going to be the Emperor. Okay. Darth Smoker. I'll be the Emperor. What you need to do is pitch me, right? Pitch me this Death Star.
Right.
You need to take me through the journey so that I can exploit the technology that is the reconstructed, the fully operational reconstructed Death Star.
Do you mind if I ask for... Sorry. Do you mind if I ask for help?
No, you can ask your clones. Yeah.
What's the power of the Death Star then? Can anyone... What's the power of this technology? Destroying planets on demand. What was it down here? Kill millions. You were able to kill millions. Deploy.
Planet.undeploy.
What was the thing when the SpaceX rocket blew up that Musk talked about? I can't remember. There was like a explosive. That was it. Rapid unscheduled disassembly event. Yeah. So the power of the Death Star, you're able to blow up planets, right? But this is Mark II of the Death Star, right? So what are the limitations? What are the limitations of this Death Star, right? What are the limitations?
What limitations did it diminish?
Yes.
Well, it has a better exhaust port than the previous model. We checked that.
Yeah, we did. Yeah,
definitely has that. But so what limitations does this diminish? Having this Death Star, what limitations does that diminish? Sorry? Rebellions, yes, it diminishes rebellions.
Yeah, it will. Yeah.
So what kind of things, as the Emperor, what kind of things do I have that are helping me manage not having one of those?
How do you compensate for not having a Death Star at the moment, I guess is another way of looking at that. Yep.
Massive Imperial fleet, right?
Stormtroopers.
Bajillions, which is a unit.
TIE fighters.
Bajillions of stormtroopers.
Yeah.
And one ERP. Clearly we're going to need ERP here. Yeah. SAP powers the Death Star. Yeah. I saw that in an airport. Okay. And so now what new rules then? What new rules are we going to need in order to benefit from this Death Star? What new rules are going to help us? Pardon? I can disband. I don't need all these stormtroopers anymore, which is fab. Yeah.
That's taking stuff out of our cost base, which obviously, as the evil empire, we're consistently trying to drive down costs. We're an efficient evil empire. That's very much the case. So that's good. Thank you. Yeah.
EY also powers. Now here's a fun thing though, right? This is where, spoiler, right? This is where the Sith come unstuck, is that they're stuck in their existing paradigm because they think that when their Death Star gets destroyed, they need a new, bigger, more powerful Death Star. Meanwhile, the rebellion are super smart. That's guerrilla warfare. Right, that's guerrilla. So they've got little bands of people flying all over the place. You cannot, unless you take out a lot of planets, right? You can't get rid of all those rebels. And so that's why the rebels always win, because the Emperor thinks if he comes back with bigger and bigger, heavier weapons, he can take out all these people. So he's stuck in his paradigm. So here we are then. We're locked in the rules. And we're locked in these rules of policy. We're locked in these rules of law. We're locked in these rules by structure, by culture, by paradigm. And so what we wanted to do was give you like a thing you can take away, a tool you can take away. Yep. So we turned this into a handy acronym. So James, you'd like to talk us through the handy acronym?
Yeah, so for those of you who don't know, I'm from South Wales originally. Dan hasn't made any jokes about me saying situation yet.
No,
or
I
limitation
haven't.
either. So being from South Wales, obviously this is spelt PLSCP. It's got the correct number of consonants for Welsh.
I believe the exclamation mark is actually a part of the word. Is that right? It's part of the punctuation?
Oh, like Yahoo.
Yes, like Yahoo.
Right,
exactly like Yahoo.
Exactly
yes.
like Yahoo, yes.
Yahoo!
Sorry, exclamation mark at the end. And
there's an intonation at the end.
Yes, you might think it's pronounced but it's not. It's
How naive.
In Welsh, that's Cynefin.
Time to first mention of Cynefin is 48 minutes?
Something like that.
Something like that, yeah. Okay, fantastic. So this is Cynefin we're leaving you with. No, we're not leaving you with that. We're leaving you with this. Technology can bring benefits if and only if it diminishes a limitation. So practice looking for those rules hiding in plain sight. Practice looking for the limitation it's diminishing. Practice looking for ways to measure that limitation diminishing. Practice thinking about what the new rules will be that will help you to exploit this new technology. Remember, the existing rules will be hiding in plain sight. They're really, really hard to spot. And once you do spot them, they're often really, really hard to unpick and to remove and to replace because paradigm, because how the organization's grown up and built its scar tissue around the existing structure. So with that, I'm going to say thank you very much. Go break some stuff.
I should point out that I asked him to say AOTB, awesome people, lovely things, not spam.
Yes, sorry about the email. That's the email address he told me to use.
Thank you all.
Thank you.